Okay, and we're back for part two of the covalent compound nomenclature. I'm getting this video made ahead of time, so you should be able to watch this prior to coming to class. Basically, just going to be running through some more examples, okay? And if we sort of revisit the objective for this lesson, you're going to be able to determine the structural and chemical formulas of covalent compounds based on its name and knowledge of functional groups. So we really just focused on the name in terms of the prefix and suffix last time. Today we're going to be working in our knowledge of functional groups. Okay, so I have sort of one more slide here to talk about, and like I said, I'm going to be mainly showing you some examples of how to use this functional groups graphic organizer to help us draw these structures. Okay, so first of all, what are functional groups? Well, functional groups are common groupings of atoms in molecular structures that appear in lots and lots of different biological compounds, okay? Like repetitively, over and over again. And so the fact that we see these groupings of atoms, these arrangements of atoms all over the place, it caused biologists and chemists to sort of give them special names and say, okay, every time you see these group of atoms together in this configuration, that is called an alcohol, or that's called an amine, or a ester, or a carboxylic acid. Okay, and if you took biology last year, it's possible that you may have talked about a few of these. So what we're going to do today is we're going to learn how to take the name of a compound, similarly to like we did last time. We're going to take the name of the compound along with some knowledge of how these functional groups work to be able to build compounds that have functional groups in them. Okay, and this graphic organizer here is something that I'm going to allow you to use. Even if we were working in person, I would allow you to use this chart here. Okay, I would not expect you to memorize everything on here. However, it's totally likely that you may end up, just like I have, sort of learning these against your own will as you do some of these practice problems. Okay, so these are all the different functional groups that I'm going to expect you to be able to work with. We've got halocarbons, alcohols, ethers, aldehydes, ketones, carboxylic acids, esters, amines, and amides. What I've got here are their structural formulas, so the arrangement of the atoms in that functional group, along with an example name. And I'm going to do 3, maybe 4 examples here in this video of how to draw a structure that has a functional group in it. And then I'm also going to talk about then how you take that structural formula and turn it into the chemical formula, right? The chemical formula meaning just the number of each element that's present. Okay, so I'll come back to this slide here in a few minutes, and I'll reference this final part of the slide here. Okay, so let's get out our marker here, and let's work with we're going to skip halocarbons. These are honestly not too important, so I have it on here just because it is a common functional group, but they're honestly kind of boring, and you can see it's pretty simple here. Let's actually jump down and look at an alcohol. Okay, so the example that I'm going to do is the example name right here, methanol. Okay, so methanol is a chemical that is an alcohol. Okay, there are lots of different alcohols. Okay, the alcohol functional group, okay, specifically, is this right here. It's an oxygen single bonded to a hydrogen, where that oxygen is single bonded to this. Okay, what does this stand for? R, as you can see up here at the top. Anytime you see R on this page, R represents a carbon chain. Okay, usually represents a carbon chain. Okay, I'll give you an example later where R doesn't, but for the most part, R represents carbon chains. Okay, and we've already worked a little bit with carbon chains, right? The last lesson we talked about these prefixes, right? Meth meaning 1 carbon. Okay, so this right here, this chemical, methanol, is going to be an alcohol, okay, where there is 1 carbon with an alcohol group, or an alcohol functional group tacked onto it. Okay, so here's what I would advise you to do. Okay, you're doing this, you're going to be doing these problems on your own piece of paper. I'm going to give you a name of a chemical like methanol. Okay, and so what you would then do, my advice to you, would be to just copy down the structural formula as written, including the R. Make sure you have these unshared electrons on the oxygen, okay? All right, now like I mentioned, R represents a carbon chain. How long is this carbon chain? Well, for methanol, right, meth stands for one carbon, so that R there is just going to stand for one carbon, okay? And then like we saw previously in the last video, this carbon is going to have hydrogens tacked onto it, right? And we have to sort of remember that carbon makes 4 bonds, right? It's got 4 valence electrons. It's going to make 4 bonds. So there's going to be 3 extra hydrogens here, okay? This is the structure of methanol, all right? Now, writing the chemical formula is a little bit more complicated than it was in the previous video. We're not just working with carbon and hydrogen. We have oxygen here as well, right? So you might be thinking, what order do these elements go? Should I write this as CH4O? Or should I write this as COH4? And there's other potential ways you could order things, right? How does this work? Well, that's what I was going to mention on this other slide here. This is the order that compound formulas usually go in, okay? It's kind of this acronym SHNOPS, okay? Carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. Usually this is the order. There are a few exceptions. It's not really a big deal for you to like know what those exceptions are. If you generally just use this order, it's going to be fine, okay? Carbon does typically come first, followed by hydrogen, then your nitrogens, oxygens, phosphoruses, and sulfurs if you have them, okay? So let's go back to the functional group page here. And so that means we would want to pick this formula here, CH4O, for our formula for methanol, okay? Now, one other thing that I do want to mention, there are some other ways to write the formulas that still convey the same information, okay? Some people write their formulas in what's called a condensed structural formula. I'm not going to ask you to do this, but basically what they do is they put this structural formula in sort of left to right groups. So this group right here would be CH3, and then this group here is your alcohol, OH. So this is kind of like a condensed version of this structural formula. Sometimes people will write things like this. I'm not expecting you to know how to do that. This might be something that you would do in organic chemistry in college, for example. And as you can see, it does mean the same thing, right? 1 carbon, 4 total hydrogens, and an oxygen. It's just written in a slightly different way. So if you want to practice and try to write your formulas like this, that's fine. But just know that this form right here is perfectly okay with me. All right? Let's do another example of a relatively simple one. Let's do an aldehyde. Okay, so this is the structural formula for what an aldehyde looks like. Let's go ahead and do this example here, methanal. Okay, we'll do this on the left-hand side here. Okay. I know this is an aldehyde. Oh, and I should have mentioned this with the alcohol as well. The way I know based on the name that this is an alcohol is because it's called methanol. Okay, alcohols are going to end with OL. Okay, alcohol ends with OL. So on this paper, I've tried to sort of underline some things that will help you when you're trying to determine what functional group is present, right? With this one here, this is called methanal, ends in AL. Aldehyde starts with AL. Okay, so all of your aldehyde compounds are going to be named this way, methanal, right? Ethanal, propanal, all right? It's going to have AL at the end, all right? And once again, we have meth at the beginning, so I know that this is going to be 1 carbon. So what I'm going to do is I'm going to copy down my, well, actually, I'm just going to go ahead and copy down this entire thing here. I know that this R is going to be replaced with something, right? The R is just a placeholder. Okay, and you can see how this is different from an alcohol, right? In an alcohol, you have an oxygen single bonded to a carbon. In the aldehyde, the oxygen is not bonded to the hydrogen at all, right? They're both bonded to sort of this central carbon. Now, I did want to mention, I mentioned previously that there are some exceptions where R does not necessarily represent a carbon chain. Usually, it represents a carbon chain, unless you're working with a really, really small molecule like methanal, okay? Methanal has one total carbon, okay? This is your carbon right here, okay? You're not allowed to have any more carbons. If you had another carbon here, that would be ethanal, right? So for methanal, this R actually just represents a hydrogen, okay? So to give you sort of a hard and fast rule, R represents a carbon chain unless you happen to be working with a particularly small molecule, meth something, okay, in which case it might represent a hydrogen, okay? Okay, so that's my formula, that's my structural formula there, and then my chemical formula would be CH2O, okay? All right, let's scroll things down a little bit, and let's look at some trickier ones. Alcohols and aldehydes aren't too bad. Let's scroll down here a little bit and find a difficult one. Let's do the ester. Okay, so esters, these are a bit more complex, okay, and so you notice there's a lot more stuff written here. First of all, you can recognize that you have an ester in your compound based off of this suffix here, -ate. Okay, so the name of this compound, methyl methanoate, that part at the end there is how you recognize that it is an ester. Once again, you don't need to memorize that, okay? I want you to be able to have this piece of paper, you know, in front of you. So you might want to print this out, or if that's not an option, maybe copy some of this stuff down onto the back of your periodic table, or just have this pulled up on your Chromebook. Any of those options are fine. Okay, so how do we draw this? Okay, well, here is the generic sort of formula for what an ester is. Okay, so if I draw this here, we're going to do this example. Okay, methyl methanoate. I have R bonded to a carbon, double bonded to an oxygen, double bonded to another R. That's called R prime. Okay, that's what that little symbol there means. And this carbon here was double bonded to an oxygen. Okay, tricky thing about esters and ethers, okay, you can see that ethers sort of have the same thing going on here with the R and the R prime. There are two different carbon chains on either side of this functional group. So if ethers and esters are sort of connectors, okay, they connect two different carbon chains together, or they're located in between two different carbon chains. So that's why in the name you're going to see two prefixes. Okay, so this one here, methyl methanoate, that tells me that my first or one of my carbon chains is going to be one carbon long, and my second one is going to be one carbon long as well. This could be ethyl ethanoate or propyl propanoate, in which case we would have 2 and 2 or 3 and 3, right? So you're going to see two prefixes. All right, so what I've done is I've drawn some little arrows and labeled some things on here to sort of help you recognize that as you work with these. So what that means is that I'm going to come up here and I'm going to erase my R and my R prime, and I'm going to replace those with the carbon chains. Both of them are just one carbon long, right? And once again, this is kind of a little bit tricky. Oh, you know what? I don't actually know. This is something that I haven't really encountered. I don't know if this counts as my one carbon. Let's go take a look. Let's Google this compound. These things have different names all over the place sometimes. Okay, so look at that. The structure there. You see how that carbon double bonded to the oxygen? There is no other carbon here. Okay, so it does sort of follow that rule from before. I'm glad I looked this up. I probably should have thought about that prior to making the video here. Okay, so what that means, right, just like without the aldehyde, if my carbon chain, my first carbon chain, is one carbon long, right, methyl methanoate, this carbon, right, is not actually bonded to another carbon. It's only going to be bonded to a hydrogen. Okay, so that is actually the first carbon in that carbon chain, the only carbon in that carbon chain. Okay, this carbon over here, though, that's my second one. That's my R prime. This one is going to need some hydrogens. Okay, so you can see how this can be kind of tricky, even for me. Okay, so here is the here's the total structure. Okay, meaning my formula is C2. What is that? 4 hydrogens, and then 2 oxygens. Okay, C2H4O2. Okay, and let's finish things up with one more example here. Let's do a ketone. Okay, we'll do everybody's favorite ketone, acetone, also known as propanone. Okay, propanone and acetone are the same thing. It's the different name for the same same compound. It's fingernail polish remover. Okay, so I'm sure a lot of you, especially the girls out there, have probably got some experience with that. Propanone is interesting. Okay, there is still these 2 R's because you do need at least 1 carbon on either side here, but all the carbons are aligned in a line. So actually, the smallest ketone that you can have is propanone. There's no such thing as methanone or ethanone, at least not in terms of it being a ketone. A ketone has to have carbon, 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 and then the double bond in the middle there. Okay, so you can see R and R prime. Now it's different from these others. Okay, it's different from the ester and the ether. Okay, there is no distinct separate carbon chain. You can see how these are all part of the same chain. That's why the ether and the ester have 2 prefixes, right? Whereas the ketone only has 1. Okay, prop. Okay, and then I can tack on my hydrogens here. 3 for each carbon. And we arrive at the structure for propanone, also known as acetone. Okay, so the formula here is C3H6O. Okay, all right. I think that is plenty of examples. We can obviously do some more of these in class, but that's basically all I'm looking for. Okay, is for you to incorporate our knowledge of these prefixes along with this chart here, or this graphic organizer that goes through all the different functional groups. Okay, I just need you to be able to know how to use it. All right, okay, thanks for watching, and I'll see you in class.